Hello and welcome to Cashmatics. This is my final lesson on vectors and we'll be looking at vector geometry. If you're new to vectors, then I suggest you watch the other two videos before you proceed with this one because they'll cover the things you need to know in order to understand this one. I'll be going through 4 examples, but if you want to try them before I go through the solutions, then just pause the video and give them a go. So grab yourselves a pen and some paper and let's crack on. Right, so here we have the first example. We've got a regular hexagon OABCDE, and the vector O to A is A, the vector A to B is B, and the vector B to C is C. In terms of A, B, and C, write down the following vectors. Now, if you want to have a go at this before I go through the answers, then please pause the video and I'll go through it shortly. Right, so here's the answer. The first thing I tend to do is label the diagram with all the information that's in the question because that's a lot of information there, and there's a lot to take in. So first of all, OABCD is a regular hexagon. Now what that means is all the sides are the same length, and that's really important. Not only that, with a regular hexagon, opposite sides are parallel to each other, okay, which means the vectors are going to be pointing in the same direction when it comes to opposite sides. So let's just put all the information on there. The vector O to A, so to get from O to A is A. Okay, so let's put that on there. From A to B, that's B, and from B to C, that is C. Okay, now because opposite sides are the same length and they're parallel, I can label those with the same vector. So that's also vector A, that is also vector B, and that is also vector C. Now the direction of the arrows are important because the vectors are traveling in those directions. So let's have a look at the first question. Okay, so O to B, and let's see what we'd need to do. We'd need to go from O to A and then from A to B. So O to A travelling along A, and then from A to B travelling along B. So that would simply be A plus B. Now the thing about vectors is it doesn't really matter which direction you take, because I could have gone from O to B around this way instead. I could have gone from O to E, which was C, plus E to D, which is B, plus D to C, which is A, and then from C to B. Now if you look at the direction of the arrows, it's in the opposite direction of C, which means we go along minus C. Okay, and these two cancel each other out. You've got a positive C and a negative C, they'll cancel each other out, and you end up with B plus A, which is the same as A plus B. So it doesn't matter which direction you take, as long as you're following the vectors correctly. Okay, let's have a look at B. So part B, we're trying to get from E to B. Now, like I said before, it doesn't matter which route we're going to take, so we're just going to pick one. So I'm going to go around clockwise. So E to O is minus C. O to A is A. And A to B is B. Okay, and that's it. That's that one done. And question C, I'm trying to get from A to D. Okay, so I'm trying to get from here to here, and I'm just going to go clockwise. So along B, along C, and then backwards along A. Okay, so B plus C minus A. Okay, now these two do look very similar, but they're not. They're different because this one here is a plus A, that's a minus A. This one here is a minus C, and that's a plus C. Okay, so the signs are really important. Right, okay, so that was a nice simple example. Let's move on to something a bit more complicated. In the second example, we've got a parallelogram, so OABC, and it says the vector OA is A, so let's just put that on there. Okay, now because this is a parallelogram, the opposite side is the same length as well as pointing in the same direction, so that is also vector A. It says OC is C, so that's this vector here, which means the opposite one is the same as well. And then we're told M is the midpoint of AC, so I'm just going to draw a line between A and C and mark on the midpoint the best I can. Now the first part, we're just going to write the following vectors in terms of A and C. So you should find part A quite easy because it's very similar to what we just did in the last example. Okay, so the vector O to B, so I'm trying to get from here to here, would just be A plus C because I'm going along A and then going along C. Or I could have gone the other way, go along C then go along A. Either way it'd be A plus C or C plus A, which is the same thing. Okay, the second part, A to C, So this is part 1, this is part 2. A to C, I'm trying to get from here down to here. I'd go along C and backwards along A because it's in the opposite direction to the arrow. So C take away A. Or I could have gone backwards along A, then along C. So I'd have got the minus A term first and then the C. Okay, so just like with algebra, it doesn't matter what order they're in, as long as the signs are correct. Part 3, I'm trying to get from O to M. Now let's see how we'd get there. We'd go from O to A, then only halfway along A to C. So let's just write that down. So you've got O to M. That is O to A plus a half of A to C. Now O to A is just A plus a half of A to C, which is this one here, C minus A. And let's expand the brackets. A plus a half of C take away a half of A. So A take away half of A is just a half of A plus a half of C. Right? So that's the final answer there. So just remember, when it comes to vectors, you can apply the normal algebraic rules. You can expand brackets and collect terms just like you would with algebra. Now let's have a look at part B. It says show that O, M and B lie in a straight line. So basically O, M and B. So basically you've got a straight line which goes through those points. But let's just see what we know about vectors to help us with that. If you're going on a straight line, then the vector cannot change in terms of its direction, which means O to M and M to B have to be parallel vectors. All right, they have to be parallel vectors. Now, for two vectors to be parallel, they're either the same or one is a multiple of the other. All right, so we've already got O to M. Okay, so O to M is equal to a half A plus a half C. Okay, and O to B, which you've already got, is A plus C. Okay, so that's O to B. So what we can see is that O to M is actually 1/2 of O to B. It's half of that vector. So if they're traveling in the same direction, they're going to be parallel, and this shows that they are parallel. So which means these have to be in a straight line. If they weren't in a straight line, if the other one wasn't parallel to it, it'd probably go off at an angle, then it wouldn't make a straight line, it'd make a kinked line. Okay, so that's how you show that 3 points on a straight line. Right, this next example is where things are starting to get a bit more complicated. Now, if you want to challenge yourselves, pause the video and give it a go. Otherwise, keep watching and I'll put up the solution. So as always, I'm going to put the information on the diagram first. So let's see what we have. We've got the vector O to A, which is vector A. We've got O to C, which is vector C. And then over here, we've told that O to A is parallel to C to B. So these two sides are parallel, which means they're in the same direction. And we're also told that CB, this length here, is twice as big as OA. So that means the vector is going to be twice as long as well. And in addition to that, we're told that M is the midpoint of AB and N is the midpoint of BC. And in terms of A and C, we're going to write down the following vectors. So let's look at part A. So this should be a nice straightforward one. And what we've got is the vector O to B. So I'm trying to get from here to here. Now I can't go along this way because I don't know what this vector is, but I can go anti-clockwise. So C plus 2A. Okay, and that's it. Part B, I'm trying to get from A to B. Now I can't get there directly, so what I'm going to do is I'm going to go around anti-clockwise. I'm going to go around this way. So I'm going to go backwards along A, along C, then along 2A. Okay, so minus A plus C plus 2A. And I can simplify that to C plus A. Part C, I'm trying to get from B to C. So I'm trying to get from here down to here. So that should be fairly straightforward. I'm just going backwards along 2A, so that's going to be minus 2A. Now in part D, we have to show some real understanding about vectors. Let's just see where we're trying to go to first. So part D, we're trying to get from M to N. Okay, let's see how we'd get there. We need to go from M to B, and then from B to N. Okay, so that's the route we're going to take, but we need to understand how to get there. Okay, so we've just realized, or we've just found out, that that whole vector is C plus A. Okay, but I'm just going to label it as A to B. Okay, which means if M is halfway, that little bit there is a half of A to B, and this bit here is also a half of A to B. Okay, so M to B is just a half of A to B, and B to N is half of B to C. So that's half of B to C. Okay, because N is also the midpoint of B to C. So let's just get these answers from over here. A half of A to B. A to B is C plus A. Add a half of B to C, which is minus 2A. Alright, so all I need to do now is expand the brackets, but let's be careful because we've got some negatives there. So we've got a half of C plus a half of A. So the first bracket should be straightforward. Here I've got a half of minus 2A, which would be minus A, because a half of 2 is 1. And let's just put that together. I've got a half of C, half of A, take away A, so a half take away 1 is minus a half. That'd be minus 1 half A. Alright, so that's the answer to that question. So it's quite a tricky one, so well done if you got there before I showed the solution. Now one last example, and this is the trickiest of them all, and if I had to guess, I'd say it's around a grade 8 or a grade 9 question. Okay, so it's going to be quite tricky, and you're going to have to use some other skills from the syllabus to actually answer this question. If you want to give it a go, pause the video and give it a go. Otherwise, keep watching and I'll put up the solution. Now this is quite a complicated question, so I'm going to go through the solution slowly. ABCD is a parallelogram. So ABCD is a parallelogram. So that's like the left side of the shape. ABE is a straight line, which means from A to E is a straight line that goes through B. The ratio of AB to BE is 3 to 2. Okay, so that to that, that's 3 to 2, which means if that was 3 and that's 2, that means this here is 2/3 of this, or this here is 1.5 of this. Okay, so BE, if I just write that down, is 2/3 of AB, and that's going to be useful for what we do next. Okay, so I'm just going to get rid of this here. And we're told BC and ED intersect at F. So BC and ED, that's that line there, intersect here at this point here. And AB is equal to A. So the vector up to here is equal to A. And AD is equal to B. And we're going to write down what ED is, so from E to D in terms of A and B. Now the reason why this information here is important is because if BE is 2/3 of AB, then that means the vector is going to be 2/3 of that vector as well. So this here would be 2/3 of vector A. Okay, and that's going to be important for doing part A. So let's have a look at part A. I'm trying to get from E to D. So to get from E to D, I need to go backwards along this whole length E to A. Okay, so I go backwards along 2/3 of A and another A. Okay, so backwards along another A plus B. All right, so let's just see what that is. So minus 2/3 A, take away another A. So that's going to be minus 5/3 of A plus B. Okay, so that's that vector there. So when I said you had to be comfortable with other parts of the syllabus, this is what I meant. So we've got some fractions here, and this is like me trying to do minus 2/3 take away 1. I'm talking about this part here. That's the same as minus 2/3 take away 3/3, which would be minus 5/3. Okay, so that's where that minus 5/3 of A comes from. Now part B of this question is actually quite tricky, and we need to understand similar triangles in order to be able to actually answer it. So first of all, let's identify the two similar triangles. So I've got triangle BFE and triangle ADE. Now if you remember, similar triangles have to have the same angles in them. So let's have a look at the angle here at A. That angle there is the same as this angle here at B, because of these two parallel lines. Okay, remember it's a parallelogram, so both those sides are parallel. Okay, and if you look at those are corresponding angles. Similarly, this angle here and this angle here, they make a pair of corresponding angles too, because of those parallel lines. And this angle here in the corner is shared by both triangles, so that's equal anyway. So what is it about similar triangles that helps us? Similar triangles are in the same proportion. So if we use this information here, okay, which I've highlighted, these two lengths, A to B and B to E, are in the ratio of 3 to 2. So if the whole thing was 5 units, so if I'm just adding these together, if the whole thing is 5 units, then this side is 2/5 of the whole length, this side is 3/5 of the whole length. Now, because these triangles are similar, the same goes for any length, okay? So this length here and this length here will be in the ratio of 3 to 2, and this length here and this length here will be in the ratio of 3 to 2, which means E to F is 2/5 of E to D. All right, so E to F, which is what we're trying to work out, is 2/5 of E to D. Okay, remember the word of means to times, so that would be 2/5 of minus 5/3 A plus B, which makes minus 10/15 A plus 2/5 B, which altogether gives me minus 2/3 A plus 2/5 B. And if you manage to get that answer without having to look at my solution, then that is absolutely brilliant, because it actually is quite a tricky question. Now, as far as vectors are concerned, those 4 examples are all I've got to show you, and hopefully you'll be well armed to actually answer vector questions if they crop up in an exam, which they probably will. So that's all there is for now, and I hope to see you next time. Goodbye for now.